Alright, logic fans, welcome to our third video on indirect proof, and I want to go over an example here where you see how you can use indirect proof to establish a theorem. So, as we know, this is a theorem of logic. It's one you've proved once or twice now using various techniques, but here we're going to prove it is a theorem of logic by using indirect proof. So, the way to do this is, since you have no premises available, is the first question you want to ask yourself, right, is what is the negation of this? Okay, so because that's what you're going to assume, all right? You're going to assume the negation of that. So, whoops, you're going to assume the negation of this guy right here. Okay, and the negation of him is just going to look like this, right? Okay, now what I want you to do is I want you to basically manipulate this until you find a contradiction. Okay, so let's get set up on our table here so you can see how this is working. Okay, so now we've got some space to work with here. So we've got this theorem. We don't have any premises, but we're going to use indirect proof, which means we're going to assume the negation of what we're looking for, which in this case is this. So for line 1, we're just going to write that this is what we're looking for. Excuse me, this isn't what we're looking for. This is what we're assuming. And what we're looking for, so that's our assumption, and what we're looking for now is a contradiction. And any contradiction will work, okay? And then once we get it, well, you'll see how we close out and you end with this, okay? But it's basically going to follow the exact same format of everything we've been doing. So what we want to do is we want to start manipulating this until we can find a contradiction of some kind. Now, in this case, it's a little bit involved how to get it. But you can get one. There's different ways to get it. I'm going to show you a way to do it in a moment, but I want to give you a chance to pause and see if you can find a contradiction. Once you find the contradiction, stop right there, and then we'll pick up the conversation from there. So pause now. All right, hope you've had a chance to pause and work on this on your own, but basically what we're going to do is we're going to start manipulating this guy, right? And we're looking for a contradiction. The good news is that we've got that A appearing twice, so we're kind of looking for A and not A is hopefully going to be our contradiction. And that gives me a little bit of a clue about how I'm going to proceed, right? I'm going to try to get the A's next to each other with and so it's a little bit hard to do. I could, you know, I've got this pesky leading negation here, so I can't use distribution, even if I were to calm this. But let's take this inside and see what we end up with. So if I take this guy inside, so I'm thinking about De Morgan's here, right, then I'm going to end up with something like this. And this is a little bit cleaner because now I've got these two negations I can get rid of. So this was De Morgan's on 2. And then we can basically just clean that up really quickly this way. So we'll write double negation on 3 and get rid of these two guys, all right? And basically what I want to do is, my strategy is, you know, I can already see the A and the not A. My strategy is to bring the A and the not A right next to each other side by side, okay? So that the contradiction is explicit. So what I'm going to do is I'm going to use a SOS to move the parentheses over. So I'm going to get A and B and not A. Okay, and that's association on 4. And then again, my strategy of bringing the A's together is just going to require me to bring the A over like this. All right, and that's comm on 5. And then, of course, to get the A and the not A grouped together properly, I'm going to use assoc one more time. And I'm going to get A and not A and B, okay? And now I don't have a contradiction yet. I don't have, you know, something explicitly of the form P and not P. But obviously I can get that really quickly just by using simp, right? So if I do A and not A, that would be garnered by simp on line 7, and bingo, I've got my contradiction. I was looking for a contradiction by assuming the negation of the theorem, okay? Now I've got it, and now that I've got that contradiction, what do I do with this assumption? I discharge it, and so it's going to behave the exact same way as everything else we've been doing on our indirect proof lessons. Okay, so you're going to get the first thing you assumed, which was this thing, and then you're going to get arrow, the last thing you got. Okay, so the last thing we got, let's give ourselves a little bit more space here, is going to be A and not A. So in this case, that's what we end up with, and that's IP on 1 through 8. Okay, and so that's exactly how it is. And notice it's just the exact same pattern as before. I assume the negation, I look for a contradiction. As soon as I find it, I discharge that assumption in the usual way. No changes, okay? And then it gets even better. The rest goes the same way too. IP, LNC, modus tollens, double negation if necessary. All right, so see if you can finish it off from there. All right, so we're going to do 11, and we're going to do 12, and we're going to have LNC. This is going to be modus tollens on 9 and 10, and this is going to be double negation on 11, and that should just about do it. So this one's going to be, it's not the case that A and not A. That's our LNC, and that's going to set up this guy, the negation of him by modus tollens on those two, like this, and then by double negating that, we end up with this, which I can reduce to just this, and notice this is what we were looking for, of course, okay? This was the negation of it that we were trying to find. So that's QED, all right? And that's how you can use indirect proof, or IP, to establish theorems, and there's plenty of practice problems with the solutions laid out in the text. All right, logic fans, keep practicing this, because we're going to use a really effective strategy in 3.9 where you learn how to combine CP with IP. So you want to make sure you've got these techniques down before we look at that. Catch you on the next videos.